Salam and good day. For our group report, our topic is regarding on home water heater system for this course of control engineering. Introducing our group member, which are Jeremiah, Jeremy, me myself Joyce, Khairul San, and Lingesh Kumar. For the introduction, what is water heater? Water heaters are familiar fixtures in most homes. They typically look like a big metal cylinder, tall drums that are often consigned to a laundry room or basement. The function of water heater is basically to heat water. So water heating is a heat transfer process that uses an energy source to heat water above its initial temperature. Typical domestic uses of hot water are cooking, cleaning, bathing, and space heating. So in this project, we are to investigate the water heater system to depict its system, development, and operation. The objective for our group project is to identify the transfer function, input and the output of the system. Secondly is to apply appropriate method to analyze the stability, steady state error, transient response of control system. Lastly is to apply problem solving techniques by using MATLAB to validate the simulation. Next, we move on to the scope of this project, or we can say the goals of this project, is to focus on deriving a transfer function based on the system under consideration and analyzing the transient response when the system is subjected to unit step input.
Hello and good day to our lecturer, Dr. Zamani. My name is Jeremy Jimbun. Metric number CD170004. Today, I will be presenting Chapter 2 for this group project, which is the literature review. So for this literature review, I will be explaining about the principles of water heater system. The water that enters your house travels through a network of pipes and is generally chilly or cool depending on the season. A water heater is required to have warm water for a hot shower or bath, as well as to operate dishwasher or washing machine. Storage water heaters typically function through the consumption of electricity, natural gas, oil or propane, with the particular energy source that is chosen varying according to availability of those fuel. So based on this figure, we can see how the working principle of the water heater system. So next, I'll be explaining about the open loop system. Open loop system is a control system which does not have any feedback connected to it. It is called closed loop system. These types of systems do not depend upon its output. Open loop systems are one-way signal flow system, as this system does not contain any feedback, i.e. the output is not fed back to the input, which is also known as non-feedback system. For example, for this non-feedback system is a toaster or a clothes dryer. So next, I'll be explaining about the closed loop system. It is also known as a feedback control system. It's a control system that employs the open loop idea as its forward path but contains one or more feedback loops or pathways between its output and input. The term feedback simply refers to the return of a portion of the output to the input as a part of the system excitation. Closed-loop systems are designed to automatically achieve and maintain the desired output condition by comparing it with the actual condition. It does this by generating an error signal, which is the difference between the output and reference input. So based on this figure or project, this is our design for the circuit design for the closed-loop system. So next is the introduction of transfer function. The transfer function is a function of complex variables in mathematics. The transfer function for finite dimensional systems is essentially a rational function of a complex variable. Also, transfer functions can be used to explain high-order systems, including infinite dimensional systems controlled by partial differential equations. So for example, this is the equation that we use for this project. C of S over R of S is equals to output over input. for our heater, GA, the equation for electric heater will be P equals to V data. Then the differential equation would be P equals to V dt over dt. Then by applying Laplace transform, Ps equals to V of S multiplied with T of S. Then the transfer function for heater is T of S over P of S is equals to 1 over Vs. Then for heating process GP, then the heat loss will be present during the process, which is H is equals to Q plus CQ. The differential equation would be Ht equals to Ha dt over dt plus Ka d capital T over dt. Then by applying Laplace transform, Hs is equals to Hast of S plus Kast of S. Then the transfer function for the process would be T of S over H of S equals to 1 over Ha of S plus Ka of S. So by combining everything, the transfer function that we get is Gc 1 over Vs multiplied with 1 over Has plus Kas over 1 plus Gc 1 over Vs multiplied with 1 Has plus Kas H. So now for root locus. Root locus is a depiction showing the positions locus of all potential closed loop poles with some parameter, commonly a proportional gain K adjusted between 0 and infinity is the root locus of an open loop system transfer function. So now for the next one is the PID controller. It is a proportional integrative derivative, or known as PID. Is the most essential and widely used controller in industrial processes because it is simple to understand and to operate. It is widely used because of its robust performance in a wide range of operating conditions and simplicity of function once understood by the processing operator. So based on this figure, we can see ET is equals to T over T minus T initial. Then applying the equation, UC T equals to KPET plus KI integrate ET dt plus KD over ET dt. So that is all from me. Thank you.
My name is Kaizul Ifan. Today I'm going to talk about the effect of P, PD and PID controller. So first of all, process control are necessary for designing safe and productive plants. A variety of process control are used to manipulate processor, however, and most effective is the PID controller. The controller attempts to correct error between measure process variable and the desired variable, calculating the difference and then performing a corrective action to adjust the process accordingly. Then much more practical than the typical on-off controller, PID controller allow for much better adjustment to be made in the system. Although there are some advantages, they are large disadvantages to using an on-off controller scheme. They are inefficient, can generate noise when seeking stability, and physically wearing on valve and switches. Then after that, we're gonna talk about the P controller. The P controller, one type of action used in PID controller is the proportional control. Proportional control is a form of feedback control. It is the simplest form of control that can be used in closed loop system. P only control minimize the fluctuation in the process variable. It provides a faster response than most other controller. Initially, only the P only control to respond a few seconds. Then the existence of an offset implies that the system cannot be maintained at the desired set point. Then lastly, it impossible to compress offset which is implicitly included with each equation. Then we're gonna talk about PD controller. Another combination of control is PD control, which let the eye control of the PIZ system. PD control is combination of feed forward and feedback because it operates on both the current process condition and predicted process condition. And also, as mentioned, PD controller correlates the controller output to the error and the derivative of the error. And then lastly is about PID controller. PID controller is a proportional integral derivative control. Is a combination of all three types of controller method. PID control is the most commonly used because it has more advantage. It also have a quicker response type. Then it also the most expensive controller. PID controller correlates the control output, the error, integral of the error, and derivative of the error. In addition to PID control, the P, I, and D control can be combined in other ways. That's all from me. Thank you.
Hello, my name is Jimmy Alec James Bailey, talking about chapter 3, which is the root locus time and frequency analysis. A root locus is a depiction showing the position locus of all potential closed loop poles with some parameters, commonly a proportional gain labeled as k. Adjusted between 0 and infinity is the root locus of an open loop transfer function, also labeled as Hs. The figure below illustrates a unity feedback of the loop transfer function. Elements are in the closed loop transfer function. I'll be showing you in the slides discussion and some research are done when doing our project. There are some equations that we can piece together to calculate the transfer function and also sensor transfer function at feedback flow. There are controllers that is controlling the upper and lower element. It is a temperature activated switch. So below are the block diagrams of our project. Here it shows the water heating system block diagram. So from the above figure, we need to use the steady state error for non-unity feedback system concept because there are transfer function at feedback flow. The figure below shows step transfer function transform to a simple flow. So this is the simple flow of our block diagram. So as for example, by using the common formula, which is GS divided by 1 plus GS HS minus GS. So GS represents the transfer function of the room controller and HH represents the transfer function of the sensor. So how to apply this transfer function formula? So as below are the calculation. As you can see, using the steady state error for non-unity feedback system, we use the formula to calculate. So to draw root locus, use the formula from above when k is equals to 1, following all the steps till the breakaway point. So using the formula, we can locate the position of zeros, position of poles. We can find the centroid, where the centroid is. So assuming all imaginary numbers positive of the square root number of asymptotes. So to calculate numbers asymptotes, we need the number of poles minus by number of zeros. We can also find the angle of the asymptotes. So after doing all the calculation, after finding the angle of poles, angles of zeros, angles of departure, breakaway point, that is calculated in the above and is stated at the graph. So here's the graph. So frequency and time response analysis. So to calculate the frequency analysis, from the equation s plus 6 divided by s squared plus 8s plus 18. So that's the GS, and we can assume HS equals to 1. S2 formula GS over 1 plus GS HS, it will be as follow. So after doing the calculation, use the second order equation of transfer function. The equation are as follow. After doing the calculation, we can now calculate the resonance frequency, which is then we can find the resonance peak, the cutoff bandwidth, peak time, peak overshoot. As you can see, the calculation are as follow. That's all. Thank you.
My name is Lingesh Kumar Analakit Nankavelu. My matrix number CD190252. I am from group 11. I am going to present about conclusion of our topic, home water heater system. Throughout this assignment, we learn a lot about the details of hot water supply and the source of hot water heater in home. There are different types of column energies for water heating. In an electric heating system, there are two types of it: instantaneous water heater and storage system. The two types of electric heating system have their own benefit and shortcomings, which we do not know much about them. We search a lot of the installation process by website and books to get more information and understand more of it, as well as the management system of hot water supply. Not only that, it also enables us to determine how to properly maintain the system so that we can avoid and prevent problems in the system and thus have a better, functional and long-term of water supply system. That's all from me. Thank you.